Welcome back to another video that's looking at circular functions. In this video, we're going to look at the particularly important topic of exact values. So these exact values are vital when we're trying to deal with problems without a calculator. So there's very few angles within the unit circle, and we'll discuss three important ones today. They're not the only ones, but three really important ones where we have knowledge of exact values. So those three angles are 30 degrees, 45 degrees, and 60 degrees. And then just looking ahead, we can use symmetry properties of the unit circle to then find exact values for different angles or other angles in the unit circle. So those three angles, if I go ahead and draw them in, the first one was 30 degrees. So that would take us to about there on the unit circle. Our next angle was 45 degrees, which would take us to about there. And our last angle that we have an exact value or set of exact values for was 60 degrees. So that would take me to about that point there. So this angle here is going to be 30 degrees. So let's just make sure that we've annotated that. That's 30 degrees. This angle here was 45 degrees. So I'll just squeeze that in there. And the last angle, which is this angle from there to there, is 60 degrees. So these three angles have nice exact values that we know for sine, cosine, and tangent. So thinking first of all of the sine values. So we want the y value at this point, so that would be about there on the unit circle. We want the y value at this point, which would be about there on the unit circle. And we also want the y value at that point, which would be about here on the unit circle. And these aren't exactly to scale, but they'll help us remember these exact values well. And there's this really good pattern. The pattern goes root 1 on 2, root 2 on 2, root 3 on 2. So I'll go with that again. It goes root 1 on 2, root 2 on 2, root 3 on 2. So root 1 on 2 is the smallest of those values. Root 1 on 2 is actually a half. So root 1 on 2 would be the exact value using this way of remembering them for sine of 30 degrees, would have a value of root 1 on 2 as its exact value for sine of 30 degrees. Root 2 on 2, which is closer to 0.7 something, is going to be the next value here. So this value here is going to be root 2 on 2. And the last value, which is the sine value for sine of 60, is going to be root 3 over 2. So sorry, just trying to squeeze those in. The good thing is that this same pattern of root 1 on 2, root 2 on 2, root 3 on 2 also applies for the cosine values, but it's a slightly different angle each time. So when we're looking, if we're going from the biggest value to the smallest value for cosine, that happens from 30 back to 60 degrees. So this value here, its cosine value would be this position, and that position relates to the root 3 on 2. So this value is going to be root 3 on 2. Then if we look at the x value for this position, that will be somewhere about here, which is root 2 on 2. And the last one, which is this value here, if we come down to the x-axis, which gives us the cosine value, that's going to be root 1 over 2. So the way of remembering these is always the pattern root 1 on 2, root 2 on 2, root 3 on 2. Root 1 on 2 is the smallest value for both. So the smallest value for sine goes with the smallest angle. That's kind of useful. So we go a small angle of 30 degrees. It has the smallest y value, which is root 1 on 2. Then if we go to sine of 45, we get root 2 on 2. And sine of 60 gives us the largest y value for all of these 3 points, which gives us the root 3 on 2 exact value. For cosine, when we go 30 degrees, we get the largest x value here. So we get x is equal to root 3 on 2 at that point. So cosine of 30 is root 3 on 2. Cosine of 45 is root 2 on 2, which is actually the same as sine of 45, which is interesting to know. And there's a reason for that. And we go to the largest angle, which is 60 degrees. And cosine of 60 gives the smallest x value of root 1 on 2. So we'd say cos of 60 is root 1 on 2, or a half. So that's a way of remembering the exact values for sine and cosine. It's a helpful little pattern of root 1 on 2, root 2 on 2, root 3 on 2. And I'd really encourage you to learn the exact values this way because it makes them very easy to recall and quick to recall. The tan values don't quite have the same pattern to them, but it's easy enough to remember. It may take a little bit more effort than the root 1 on 2, root 2 on 2, root 3 on 2, but it can be done. So the tan value is the y value at this point. So the y value at that point for tan of 30 is root 3 over 3, which is also equal to 1 on root 3. So if you know how to rationalize the denominator, you'll understand why those two values are actually the same. But just be aware that if you're asked to find the value of tan of 30, its exact value is root 3 on 3 or 1 on root 3. If you want the exact value for tan of 45, this one's the easiest to remember, I feel. Because tan of 45 says you go for a 45-degree angle, one out and one up. And in the unit circle, if you've gone one out, you're exactly at the tangent line, and one up, that gives a value of exactly 1. So tan of 45 gives an exact value of 1. The last one, which is tan of 60, you go all the way up to this value, and this has an exact value of root 3. So for the tan exact values, there's not quite that nice pattern, but they all seem to relate to 1 and root 3. So we have 1 on root 3, or root 3 on 3 for tan of 30, and it's the smallest y value, so it's with the smallest angle for tan. Then we have tan of 45, which gives a exact value of 1, and then tan of 60 gives an exact value of root 3. And now stick around for more videos where we'll go through a lot of examples and problems where we're trying to find exact values that relate to 30, 45, and 60. For example, we'll even get to the point where we're trying to find cosine of 135 degrees, or we might be trying to find sine of 300 degrees, and we're going to use our understanding of these exact values as well as symmetry in the unit circle to do that. So stay tuned for those videos if you want to see how to find exact values in other quadrants of the unit circle. So we'll wrap it up there and stay tuned for more video examples.